Hello everyone, welcome back to my channel. Today let us see some topic in file structures, subject code 18 by S61. Myself Sandesh Kodavi, studying in Sri Venkateswara College of Engineering, Bangalore, Department of Information Science and Engineering. Today the topic will be about the multi-level indexing with B-tree. Multi-level indexing. What is multi-level indexing? In file structures, right? We are discussing about all this topic will be based on the file structure, how the data will be organized and how the data will be fetched in file structures, all those things. So multi-level indexing. Multi-level indexing is a hierarchical approach to indexing data in file structure. So as you know that the indexing where it will come in array, right? To store whenever we are storing the data in array, the indexing will come there. So in the file structure as same as the that like that only, in the file structure also it will come. The multi-level indexing is the hierarchical approach to indexing data. So how will assign some values, the index values to the array, right? So same like that only in file structure also we are assigning some values to the files. Um, it involves organizing data into multiple levels of index structures to facilitate faster and more efficient data retrieval. Why we are uh, indexing or why we are introducing multi-level indexing is to facilitate faster. So whenever we want to fetch data or retrieve data from the files, so it will be the whenever we do indexing, the it will be very easy to fetch faster and effective data. Whatever the data you need, you can be fetched faster than the normal file structure. So in each level of index narrowed down this search space, leading to improved performance. Why you use multi-level indexing in file structure? What is the use of that? So let us see that the multi-level indexing offers several benefits in file structures. Improved performance. So how will improve the performance? Um, Well, introducing the number of it reduces the number of disk access required for searching, leading to faster data retrieval. So, if you do multi-level indexing in file structure, it reduces the disk access required time. What are the disk access right requires for searching? That will reduce, leading to the faster retrieval and effective use of storage. Multi-level indexing optimizes storage utilization by organizing data in a hierarchical structure. It will be the data will be in the files like in a hierarchical way. How the tree will be right in tree like that will be the hierarchical way, one after the other, one after the other. So it will be like in branches. So whatever the data we have to fetch, right? So it is very easy to fetch if it is there in hierarchical structure. So next, scalability. It allows file structure to handle larger amounts of data by uh, prioritizing it into smaller index structure. Next, flexibility. Multi-level indexing enables dynamic index maintenance, making it suitable for file system with uh, with effect with frequent updates. B-tree. What is B-tree and overview of that B-tree? B-tree are balanced tree structures commonly used for indexing in the files. Next, they provide effective search, insertions, and deletion operations. B-tree provides effective search, insertion, and deletion operations. Same as the whenever we insert the anything into the B-tree, right? The smaller value, then the root value will be the left side to the B-tree and the left node of the B-tree, and the greater value will be the right node of the B-tree. So next, a B-tree is defined as the following properties. All leaf nodes are at least at the same level. So whenever we consider a B-tree, right? So the all leaf nodes are at the same level. If it is not turned at the same level, then we will not consider it as the B tree. Each node can contain multiple keys and pointers to their child nodes. Uh, the key within a node are stored in stored order. The number of keys in each node is within a specific range. B tree structure. So you can see how the B tree structure will be there. Let me see that. Let us take a closer look at the structure of B tree. Each node contains a flexible number of keys and pointers, and the number of keys in a node is always one less than the number of pointer. The key is a node and stored in a sorted order, and the pointer is a node points to the child node or data blocks. So this is the how the structure has to be in the B tree. B tree search operation. How we can search the data or node in the B tree. Let us see. Searching in a B tree involves the following step. What are the steps has to be followed while searching the tree? Start at the root node. Let us start from the root node. For example, let us consider this is the root node, and compare the search key with the keys in the current node. If the key is less than the current node, so let us start. This is the let us construct on B tree, right? So let this value will be um, 4, and this will be 2. This is 5. Let this will be 1, 3. This is 5, right? Now let this will be 6. 5 and 7. So let us start from root node. Compare the whatever the key we have to search, right, with the keys in the current node. If the key is found, search is successful. Whatever, for example, if we are given key is equals to 4, right? This 4 is a root node here. We'll start from here. If it is found at the root node, the search is successful. Otherwise, if we want to search, for example, let us take as 3. We want 3 to search here, right? If the key is less than the current node, move to left of the right. Yes, if the key whatever we want given key to search, right, if it is key is less than the current node where you are there, we are in root node. So 3 is less than 4, we are moving into the next child node, right here. So here again we are checking the current node. If it is greater than that current node, we have to do move right. So 3 is greater than 2, so we are moving right. So here we have 3, so it is found at the we can So by this way, we will search. The search operation will be done in the B tree. Repeat step 2 and 5 until the uh, uh, key is found or a leaf node is searched. So this is how the search operation will be done in the B tree. How multi-level indexing with B tree works. When a user searches for a record in a database, the search begins at the root node of the index. Absolutely, it begins at the root node in the index. Okay, the search is so the keys in the root node are compared to the search key, and the node that contains the closest key identified. The search then continues recursively on the child nodes of these nodes until the leaf node that contains the key is found. As I showed in the last slide, uh, the same operation will be done with the multi-level indexing also. Example of a multi-level indexing with B tree. Root A, B, C, D, E, F, G, H, I. So this is the index values of the B tree. Next, search for a key C. Search begins at a root node A. First finds the key A. The search then continues on the child node of the root node that contains the key A. The search key C is found at the leaf node and the record with the key is returned. So conditions. What is the search operation to find the key C? Benefits and multi-level indexing B-tree in file structure. Multi-level indexing with B-tree provides several advantages in file structure, reduces disk access. So as I told in the previous slides, it reduces the disk access because the representation of file structure in a hierarchical way or a data in a B tree, the data can be fetched or retrieved faster, right? So it reduces the disk access. The hierarchical structure allows for the faster data retrieval by minimizing disk access. Effective use of storage. Only a portion of the index needs to be loaded into memory, optimizing storage utilization. So this is how it reduces the disk access. Whenever we don't have indexing, right, the each file memory or data is to be loaded into the disk access, so that takes more time. Only the portion of index needs to be loaded into the memory. So index values is to be loaded into the memory, right? So it takes the less time and it reduces the disk access and optimizes the storage utilizations. Next, scalability. The index structure can handle larger amount of data by promoting it into smaller subsets or regions. By making indexing, the the structure can be handled amount of data by promoting into smaller subsets or regions. Dynamic index maintenance. The structure can adapt to change in the file system by dynamically adding or removing index labels. By We have reached the conclusion of this section. So multi-level indexing with B-tree is in a file structure is a powerful technique or for effective data retrieval. It's a powerful technique with multi-level indexing with B-tree is a powerful technique in the file structure for retrieval the faster uh, retrievals. So it offers improved performance, effective storage utilization, scalability, and dynamic index maintenance by organizing data in a hierarchical structure. Multi-level indexing reduces disk access and speed up data retrieval operations. B-tree provides the underlying structure for implementing multi-level indexing in a file system. Uh, Sharing using multi-level indexing with a B-tree when designing file structure that requires faster and effective data access. If you like my video, do watch, like and subscribe. Thank you.